and welcome everyone. Welcome to my talk. So, my name is Andy Collon, and I work for ThoughtWorks here in London. I'm primarily a developer. I started my career in a world where there was a distinct line drawn between developers and operations. The famous "we build it, they run it" way of working. And over the last few years, I've been fortunate enough to spend a lot of time with clients and teams that either automate their infrastructure management or create their infrastructure through code. The client team I'm currently working with is a product team responsible for delivering business-serving APIs and services, and as part of delivering this, manage quite a large estate of Windows boxes. Okay, so what the talk is about. So today, what I'll be talking about is the journey that the current team has been on, a journey that started a long time before I joined, and what you hear about is some of the challenges that we faced, some of the wins and losses along the way, and how a continual reflection on our direction and our motivations have helped to put us in a good place for future improvements. So we'll start off by looking at the organization and a bit of the organization's tech journey, then the team itself, who we are, what motivates us, and how we work together. We'll talk a little bit about the tech stack, so you can get a feel for the kind of stuff that we do, sort of what technology we use, what we use it for, kind of what our role is in the business, and how technology contributes towards that. And then I'll tell a few stories, some of the events that kind of helped shape the way that we use technology in the business. And I'll wrap up with some thoughts that summarize the lessons that I think we've taken as a team from the stories that I'll be sharing with you. Okay, so to start, the organization where we work, it's a large multinational retail company. I can't name them for various reasons. They've been around for quite a long time and have quite a number of legacy systems. They had an initial core set of technology, and then as technology kind of advanced through the years and their requirements changed, they would look for kind of new technologies to bring in, and because the existing technology ran critical business functions, that tended to stay. So new technology was brought in, and a legacy system was created once more. So basically, they have a legacy system, sitting by a legacy system, probably wrapped by some kind of legacy abstraction, and then more legacy systems. And about 8 years ago, the business realized that actually this was a bit of a pattern that they were getting into. So a bunch of architects within the system tried to make moves to get out of that pattern, and they realized that one of the ways to do that was to structure the business differently. So they started to structure the business around product teams. So teams that had an ownership of a particular concept within the business, such as identity, product pricing, customer contact, and that kind of thing. So then these teams would start expressing themselves through APIs. So they would own that responsibility within all of the various legacy systems. And that's kind of where our team came in. So our team is composed mainly of developers. So we have, 18 developers. We've got 2 product owners or iteration managers. And we're a small part of the larger organization's tech team. We own a specific part of their domain. We support a number of APIs in the domain of customer communications. So I think it's useful to talk about the team up front, as it'll probably help you visualize the stories that I'll be telling you in a bit. Also because the teams have changed quite a lot since I've been involved, and it is a constant question as to what the team should be, how we should behave. Does the sub-team shape make sense? And I think it's a very valuable behavior, and it helps us to keep us in the mindset that change should be kind of a goal for us, rather than something that we're that we have to struggle with, that's imposed upon us. It's something that we kind of strive for. So I've got a couple of quotes up there. So naming things is hard, as we all know, and to see is to forget the name of the thing one sees. So it's kind of talking about how difficult it is sometimes to find the concept name to fit to a thing, but also about how once that thing has been named, once it has a conceptual association, how difficult it is to see the detail within that thing. So the concept can blur the reality or the kind of deal. So our teams have had a variety of strange and kind of unusual names along the way. So when I joined the teams, there was 4 sub-teams, and they were named they were named milk, rum, beer, and tea. Each one of them had like specific roles within the team at large. The names had nothing to do with any of those roles, but they did give identity to the people within the team. It transitioned to that from a kind of a wild animal and elements of nature kind of theme. So tiger, cobra, fire. Again, didn't really relate to what the teams did, but was a fun way to kind of give identity to the people that were in the team. And it could have escalated. It could have went on and on. It could have been cat names, animals, cars, memes. It could have been anything. And people have discussed that in the past. But what we've settled on, kind of recently because of changes to the domain, is more product-oriented names. So the team is now split into 4 sub-teams, kind of that relate directly to 2 subdomains, so 2 name subdomains, which have APIs that they kind of wrap, consents and address book, and a team that's responsible for the kind of the moving parts of the stuff that we do. That's called engine, and a team which is basically responsible for doing Windows updates and doing some of the core tasks that doesn't really fit in a domain responsibility, and that's called core. So let's get back to, so onto the tech stack, sorry. So the tech stack has evolved from pure Microsoft sitting on Windows to Microsoft sitting on Windows and Linux, mixed in with JavaScript running on or in Amazon. Initially, we had a single Visual Studio project housing our service API, admin websites, services, and applications that sat on various boxes in our estate. And this was an ecosystem all to itself, and was one of the reasons we found it difficult to get a reliable deploy pipeline working. So when if I refer to the monolith later on, this is what I'm talking about. And to paraphrase Conway's law, code evolves in accordance with our relationships and conceptual boundaries. And so our team names have kind of helped us to get to a point where we have kind of more reasonable APIs. In addition, if we throw in some strong domain concepts and have a boundary within them, within which a team's closer knit, then just a second, I'm just trying to work out can I get some technical help here maybe? It's just having some issues reading all of my huge presenter notes, I'm afraid. I've got a massive script and I can only read half of it. So it's like all that there. So I was scrolling down and it seemed to be changing the... Yeah, just make it a little bit smaller, yeah, that'd be cool. How's that like?
It seems to be quite sensitive.
Yeah, it is. So we've got, thank you. So let's go to our tech stack and then, okay, sorry about that, everyone. Okay, so within the structure of the new teams, we've found a place where we can kind of describe our APIs, and our APIs tend to kind of reflect the way that the teams are set up. So we have, within the address book team, we have got our internal structures, kind of, our interface to other teams is our API. And it's the same for consent, and it's kind of the same for engine in the way that they build their teams. So our biggest code base is still the monolith, but we're moving away from it. And most of our deployable code nowadays is AWS Lambda. It's most because kind of a reflection of the size of a Lambda app. So what we've done is a Lambda app would tend to just respond to an event, and that used to be the responsibility of like a whole piece of kit. So like we would have a listener dispatcher, and that listener dispatcher would listen to the events within the domain and then pass it on to a function within the listener dispatcher. Now what we've done is we've taken out that event handler and we've kind of exposed it. We've given it a bit of identity and we've promoted it to a Lambda function. So they're not kind of constrained to daily deploy. We deploy them when they're ready. It tends to be kind of daily, but that's really just to do with the kind of the frequency and the time it takes just to do a bit of code. So it takes us a day to do code, so we'll deploy every day. It takes us half a day to do we'll deploy half a day, every half a day. So one of the reasons for that is because we've got a lot of confidence in our Lambdas. We have DLQs to support kind of any asynchronous failures. We have canary deploys. We have full automated testing around them. And we have kind of a really reliable pipeline. So it's at the point now where we could pretty much from code deploy, just leave it to go into production. Yeah. And if anything went wrong, it would get rolled back automatically, and then we'd be able to address it. This is all stuff that we've learned kind of just over this year, really. We've only just started working with Lambda. It's not particularly what the topic of this talks about, but it's been a very interesting learner journey. I think Lambdas has given us a lot of kind of confidence in what we can do in the future. So the more issues that we get with the monolith system, the more we're inclined to use Lambdas for that. So next in size after the Lambdas are a number of APIs which we've written in ASP.NET Core 2.1. So these have teased out some of the domain logic of the monolith, and by the magic of the team names have given their own interface to the world. Relationships with other APIs are built up around the published APIs, and rich domain events kind of help to interconnect everything. And so as an organization, TIBCO has historically been the queuing technology used to support the monolith's async message passing and work management, and this is hosted on-prem. We use Couchbase to store customer contact information, and that's hosted on-prem also, managed by a separate team. So that gives you an idea of our tech stack. We do use kind of other components. We use quite a lot of stuff in AWS, but that's not necessarily anything to do with our daily deploy requirements, so I'll not go into that. So we have a bunch of support and tech that makes it possible to do our deploys. We have TeamCity and Jenkins because we have a requirement to do Windows builds and a requirement to do kind of any Linux builds as well. So Jenkins gives us the Linux builds. TeamCity has the Windows agents. We're looking to change that in the future. That's kind of one of the things I'll mention. Deploys currently through Jenkins or Octopus. So if it's Node or if it's .NET Core, it's Jenkins. If it's via TeamCity, it'll tend to be Octopus. And we have moved to Octopus recently for our on-prem deploys from Nullio, our CA release automation. I don't know if anyone's kind of familiar with CA release automation. That was provided to us by the business, by the organization. We kind of had to use it for a long time, and we found countless issues with it, which I'll kind of discuss later on. We've recently moved to Octopus. We made the decision and kind of challenged the business to kind of give us permission to allow us to use Octopus to set it up because we kind of had used it previously. And Octopus has just been a big win for us. So I'll kind of mention that later on as well. We use GitHub. GitHub is our source control. Splunk is where we dump all our logs. And that's where we get our alerts from. And the content of those logs coupled with Xmatter's escalation management gives us our kind of and-on code on production issues. We do have App Dynamics as well, and it's helped us in the past with certain issues. But at the moment, it's not one of the primary tools that we use. I think it's skills as much as anything else. Also, I think as we started instrumenting our applications, we instrument in the monolith, but then because we were ASP.NET Core 2.1, or I think it was 2.0 at the time, App Dynamics didn't have support. There was no plugin for App Dynamics at the time. So I don't know if that's changed now. We may revisit it, but it's not really been higher on our priorities. So. And we lean on Chef to help us automate our Windows updates. Okay. So the stack I've just described, as I said, it powers a fleet of API servers that are available externally via Apigee. Most of our clients are internal, but not all are on the same network. And our policy is connectivity via Apigee to give us flexibility when it comes to hosting environments. We may be in one data center, load balance to another one, or one exclusive V, or we move to the cloud or a third data center. So the interface via Apigee has kind of been imposed upon us, and I think it's kind of a good way to go. We take requests from other API teams and send customer and supplier emails, push messages and text messages. We're also the place an API team would go to get a customer's or supplier's physical addresses for deliveries, etc. And as well as this, due to the GDPR rules that recently came in, we manage customers' communications preferences and consent. So that's what the tech does for us, just for the business. Cool. So I've gone over the team structure. So it's a small team comprising an overall 20-man team sharing practices and environments with some crossover in domain responsibility. And hopefully that'll help, that little outline will help kind of when I describe the stories coming up. Okay, so there's not a lot of technical detail in the talk. I've chosen instead to replay some stories. It's episodes that have occurred in this team's life that have had a major impact on the way that we've done things. So things that have broken, things that we've reflected on not being quite right. And we wouldn't be where we are today without all of these things, even though we would not have chosen them to have occurred if we had the choice. And I'm going to start with how we started to think that daily deploys was kind of achievable in the first place. So, towards automation, this is from last year. Last year, the only thing that we were deploying was the monolith. And we were deploying a Visual Studio solution which would build a package. That package would be 0.5 gigabyte in size, 500 megs, and that would get pushed out to our servers, every single server that we had. So all of the API servers, the web servers, the content servers, management servers. So like imagine 100 servers all having this like 500 megabyte package posted onto them, and then some kind of complicated PowerShell mechanism to get whatever needed to be on that particular server onto that particular server. So some of that was automated, some of it was not. We didn't do very regular deploys. It could be up to 6 weeks between deploys because the business would ask for big changes, and we put the big changes in. We'd be cautious about deploying regularly. We didn't want to break stuff, and because one of the consequences of breaking stuff was that people wouldn't get emails. People wouldn't get password reset emails. People wouldn't get kind of delivery confirmation emails. And like, that's quite important. You know, I mean, it's core to our domain, but also it's core to some businesses and how they work. So there are always quite a lot of complaints. It's quite visible when things go wrong, so we're quite careful with that. And we would have, as well as a long time between deploys, and probably because it was a long time between deploys, it could take a long time to fix a deploy. So if a deploy went wrong, it could take up to 6 days to fix it whenever there are issues, partly because it would be something new, because we would kind of patch as we went along, and also because we'd lose the skills. We'd lose the skills to identify what went wrong with the deploy. So we had to reacquire the knowledge, and then we had to diagnose issues, and the infrastructure that we diagnosed them on was rarely touched. We just wouldn't kind of get into that. So one of the kind of biggest problems there was that we had a monolithic code base with a lot of interdependent services and APIs, all part of the same release package. And a standard deploy might involve 20 web API servers, 14 application servers, reverse proxy servers, management server, content server. And one of the issues with that was just knowing what had went wrong, or what had went on, what had went right even. So before we could have any confidence that we'd done a successful deploy, we needed to go onto each box. We needed to remote desktop into each box. We needed to look at the logs. So none of this was available to us externally. We didn't have any kind of central login facility. Splunk had just been made available by the business, but it was in no way it just wasn't production ready. We couldn't rely on it at all. We didn't have it set up on all the servers anyway. And it wasn't going to be available for months. So we identified kind of visibility of successful releases as being the first thing that we needed to get. So we wrote our own monitoring tool. So we wrote a monitoring tool which would check which versions that we had. It would report it back. It would email us if there's any discrepancies. And we had an admin system which would be able to display this data. So it was backed by SQL Server. It was all custom, but it did exactly what we needed to do. So that was the first step. So we could do a deploy, and it didn't take us, say, 5 hours to check that that deploy was actually successful. We could have a bit of confidence in there. And then we had other issues. So we had issues with the proxy server. The reverse proxy servers would just fail randomly. Whether it was shutting down IIS didn't work, starting up IIS just didn't work, copying the files in, had permissions issues, or various issues that just would classify the reverse proxy server deploy as a flaky deploy. But that was within our control, so we spent time on that. After we had the measurement in to say that it was a successful deploy, we could work on the reverse proxy server. So they made them unflaky, and then we could have more confidence in the deploy, and people would be comfortable pressing the button every day. And that's what we got to. We got to the point where we could do a deploy, we could have confidence in the deploy, and we could go for lunch. We could have it finished by like midday. Like if we had like a 9:30 stand-up, we agreed we were going to do it, start the deploy at 11, and be done by 12, which is just unheard of. It was like it just wasn't available to us before. And then at this point, all that we had left was just network issues. So we had more network issues than we thought we should have. Nolio at the time, or say release automation, tended not to deal very well with them. So this is one of those reasons why we went to Octopus. But we had what we kind of aimed for. After a fair bit of work, manual work of our own, we had a daily deploy, so we celebrated it. So every day at stand-up, we'd say, right, Kit, what are we on now? So 10, 20, 30, I think it got up to 30. And then because of things out of our control, it didn't get beyond 30. So we're on quite a good run. We're fairly, so towards the end of last year, we're in a fairly good patch of kind of daily deploys. We're fairly happy with the progress that we've made. And then in the run up to Christmas, like most organizers do, I suppose, is we kind of all sat down, and some of it was imposed on us, but some of it we agreed. We thought essential changes only, code freeze. So probably like mid-November, so like around now actually, I think talk is again kind of about kind of code freeze now. We did a code freeze. So we didn't do any deploys because there's no changes to the code, so let's not do any deploys, let's not touch the production system, because if we do, something horrible might go wrong, and it's peak time, we don't want that to happen. So we went to other tasks. So we started creating dashboards, we started kind of reflecting on what went wrong and how it could have been better. So we started using App Dynamics a bit more, and we just recently kind of instrumented the monolith with App Dynamics. So we started having a look at the dashboards in App Dynamics, having a look at the models and stuff like that, and then we started to notice there was quite a lot of red on App Dynamics, and it was like, well, that didn't really mean a lot to us, but kind of suspected that red's not a good sign, so we started looking into it and bringing up some other dashboards, and this is after like 3 or 4 weeks of like no deploys, and basically what the red was telling us was that our 20 API servers were just consuming more and more memory. So we had some split dashboards, and that showed us that over the 3 weeks, the memory usage was just on a kind of upward trajectory with no abatement at all. So never like, even though we kind of expected maybe the garbage collection would come in and kick in and kind of tidy up a little bit, nothing was kind of happening towards that. So we looked further into it, and it turns out that actually the traffic patterns that we had at the time didn't justify the memory increase, and the only answer really was that it was a memory leak. So we looked onto the servers, we found there was an issue. It was an issue with a component. It was actually an issue that had been reported by Coverity, but we'd ignored because that wasn't built into our kind of automated kind of testing. But it was because we weren't doing a daily deploy. Like when we did a daily deploy, we didn't have this issue because the apples would get recycled and everything would restart. Without the daily deploy, code didn't get refreshed, and we had a memory leak. And we kind of, once we discovered it, the question really was it a good thing that we stopped deploying? I'm not really sure, because we probably should have caught it anyway. But because we stopped deploying, we had that issue. So we had the memory leaks issue, and we found it because we were playing around with kind of map dynamics and kind of dashboards and stuff like that. So the lesson that we took is don't stop daily deploying anyway. So we depend on a couple of on-prem data stores, Couchbase and Oracle, for completely different scenarios. Couchbase is used to store contact information for customers and suppliers while they register, and before the composite information from that registered person is available to populate downstream systems. So the Couchbase storage itself is a crucial part of our infrastructure. And the way our data centers are set up, we have a primary data center and a failover data center, and our API servers all have equivalents in both data centers, and it's the same for our Windows services, the listeners and the dispatchers. And it's not very often that we have a complete failover of one or another data center. So when it does happen, we have a lot of major decisions to make, like in the moment. One such moment occurred a few months back when there was a power issue, and we lost our primary data center. So whilst we were figuring out how to switch traffic from DC1 to DC2, we realized that one of our dependencies was failing and was not in a position to switch as replication wasn't enabled. So we'd expect Couchbase to be set up with replication, but it wasn't. It was set up by an external team. We didn't have any say in how it was set up. It was a managed service, but it wasn't managed by kind of AWS or anything. It was managed by kind of the business. And it wasn't really set up the way that we expected to do. We've since worked with a team that owns that technology, and now we're trialing dual DC running, which brings it in line with our overall DC strategy, which is basically live. And for Oracle, a long time ago, we had a requirement to perform an action on a schedule. The action was prompted by a typical queue, but wasn't to be actioned immediately. This is about 5 years ago. We would take the information from the payload, and that would tell us when to perform the action. And it was a push notification that we sent it out. So at the time, we used technology in Oracle. So the message queue within Oracle gave us that. We didn't use Oracle for anything else, just the message queuing. And everything was fine until a few months ago, we started seeing a failure in one of our integration tests, push notification integration tests, as you would imagine. And it looked to be like environment specific, because we hadn't changed the code at all. There were a few dependencies, and it's legacy code, so it took a while to work out what was going on. And what was going on was that the Linux server that Oracle was running on had a corrupt disk, and the Oracle instance was failing. So we asked the Oracle team to look at it, and they asked the Linux team to look at it, and eventually we discovered that the disk that hosted all of the Oracle data was gone, never to return. So it failed our integration tests, and it put us in a difficult situation when it came to the daily build, as we couldn't proceed with a failing PPE, a failing test environment into production, so it kind of held up our production releases for quite some time. But then we looked at the code, and we looked at the incoming messages to the queue, and we found that no one was using the scheduled push notifications. And we discovered that the Oracle code just wasn't touched. Whilst this was occurring, we were communicating with the team who had initially requested the functionality, and while back in the day it was required, and it required us to bring in a new database technology, they didn't need it at all, and now they could work out themselves how to kind of do the scheduled tasks. So for us, the lesson that we learned here is if the provided technologies from the management from management servers are frictionless and do what we need them to do and are in line with our DR strategy, then we don't worry about them. They're another team's responsibility, and we're happy to delegate that responsibility. But when a change to a process or setup is needed, it can be difficult to get stuff going, kind of in line with our timelines. We've got different motivations, and we answer to different taskmasters. So similar to kind of one of the solid principles in development, when we're thinking about how to structure code, we adhere to the single responsibility principle. So code should have only one reason to change. Likewise, sort of our team has one reason to change, and that's the overall domain. It's our it's our taskmasters within the domain. So if we owned the Couchbase setup, that could also be controlled in line with our reason to change. Because it wasn't, it caused friction within the production environment, and kind of we ended up in a situation where we had no primary database. So we've made the decision to move from Couchbase, and because we no longer depend on Oracle in test or production, we can get rid of that. So we delete that code. It makes our development environments a lot more straightforward. And also, it's kind of taught us a lesson as well in that in the future, whenever we consider a new technology, we need to be really, really careful about choosing something we don't have a good knowledge of within the team. We've had that recently with choosing. So by default, we'll go to DynamoDB in AWS. We had an option to use Aurora because the data structure that we kind of wanted to use felt like more of an Aurora fit. But the team kind of pushed back on it, and it turns out that we just had to use DynamoDB. We used DynamoDB in the end because I think Aurora kind of didn't actually fit exactly what we needed. But we probably wouldn't have questioned it if we hadn't had this experience. So the team as a whole just said, let's pay a lot of attention to kind of these decisions that we're making and ensure that everyone can support whatever kind of technology we bring in. So that's what we do. So one of the things that we learned from kind of last summer of like data center fragility really was that when we made the decision to shift traffic from one data center to the other, it was quite an involved process, lacked clarity, lacked documentation, and tooling support. So the way we did it at the time was cutting off traffic to Apogee by switching off IIS. So this worked, but it was a very manual process, and it was done at a stressful time when it came to switch traffic back. We weren't really nervous, but there were some doubts as to which servers and which techniques have been used to switch traffic, and therefore what would be required to restore traffic, and not a position you really want to be on your production systems. So one of the guys in the team spent a bit of time and came up with a traffic switcher that can be run from Jenkins and makes changes to Apogee automated. One of the key takeaways for us is that our teams had access to Apogee. That's the first thing. We were using Akamai before, and we had no access to that whatsoever. It was completely managed separately. And we have access to the APIs, so we can make changes. We can control kind of production traffic. And at this point on, from Apogee, basically we've got some network load balancers and we've got some VMs that are managed by another team. But other than that, we control traffic kind of top to bottom in our application, which I think gives us a lot of power and allows us to create things like this. So it allows us to create tooling that lets us do automated data center switching. And once it's switched, once we've got data center switching as a thing that we can do, we have that as part of our daily deploy. So we do a data center switch off, we switch off DC1, we switch on traffic to DC2, switch traffic again, and then do a daily deploy. It's like a little kata that we do every day. So it switches responsibility, every person in the team, every single 21 of us, so every one of us except for the PMs, do a data center switch and a deploy. So during this month, I've done it twice. Everyone will get a chance to do it. And I think that gives us a lot of confidence when it comes to kind of any DR situations. And also it's given us a bit of an advantage in the Windows update space as well. So for the Windows updates, what was originally a totally manual job is now automated using Chef and Jenkins. It's well documented and understood. The process for our 100 or so servers, which have various areas of responsibility, is to set attributes via a Jenkins job that would then be applied to machines that we target based on tags or banks. That allowed us to take out a bunch of servers at a time whilst leaving cover for their roles within the domain. As traffic was spread out across DC1 and DC2, when we updated our application servers, we had to have a very careful balance of machines so that traffic wouldn't be affected. So with the work that we did to automate the data center traffic switching in place, the whole Windows update process has kind of just been revolutionized. It becomes a lot more straightforward. It's one button click to switch off all traffic to a certain data center, pile all of the machines in that data center into one tag or one bank, and then run all the Windows updates. They'll leave it like half an hour, make sure it works, and then kind of you can switch off to the other ones. It's not quite as straightforward as that, but instead of having 20 banks and a lot of manual process, it's 4 banks, and it's really quick. And we'll probably want to automate this a lot more. The fact that we have a process that we can run means that we can put a button behind it. It means that we can automate it. Means we can we can code it up. So where we are is we've currently deployed the main legacy code base to on-prem Windows servers for the last 30 working days without interruption. Actually, this is true of Tuesday. As of Tuesday, we deployed 30 days in a row. As of Wednesday, we did not. There was a VMware issue, nothing to do with us, but we can't take that and it doesn't allow us to continue our streak. We're being very honest with ourselves. So we're on a streak of 2 at the moment, and our record's 30, and I think that's fine. We're okay with that. Sometimes we just don't have control over every single thing in our environments, and that's understandable. What we have done is we've learned the things that we can change really do help us get to where we want to be with daily deploys. So I've said we're switching data traffic on a daily basis, data center traffic on a daily basis. We're all getting a chance to do daily deploys. Future plans are we would like to move to Azure DevOps. I think one of the things that's kind of a bit of a negative for us is the fact that we have to use Jenkins and TeamCity. We'd like to just have one place where we do everything. So Azure DevOps could potentially be a good solution for that. We move a lot more stuff into Lambdas. That gives us a lot of control, a lot of confidence in our deploys. And that's it, really. I think so aiming for the daily deploy as a shared team goal has really helped us focus on kind of improving in our tooling and kind of how we work together. It's simplified our domains and the dependencies between the domains, and taking control of the process has given us a lot of confidence that we can kind of feed into this kind of for the future. Also, the fact that the data center switcher fed into the Windows updates is something that we kind of start to expect now. So we try and do good things. We try and to communicate those good things within the teams, and it turns out that actually we can share that knowledge and we can share those good things, and they can help us collaborate and kind of work on new ways to work together better. Cool. Right. So hopefully, I've given a flavor of kind of the gains our team have made in pursuit of working practices that felt right. I think a lot of us have come from companies where we just expect things to be automated and to work kind of seamlessly and do deploy on a kind of regular basis. This wasn't the case here, but the fact that we have that meant that we knew that we could achieve it, and it gave us kind of goals to aim for. I'd certainly credit the nature of the team to our manager. and also the flexibility of the organization, I think, has allowed us to make these changes, and I think it's really important. So that's it. That's all I had to say. Sorry, it wasn't very technical. I hope some of the stories have been interesting to you. They certainly have been it's been a good journey for me, to be honest.
Thank you, Andy.
Yep.
That was really good. It was a really good, honest story, I think, about the journey that you've been on and the team's been on. And good to see your presenter notes here as well.
Yeah.
And see that it's not only me that occasionally falls into the trap of writing far too many presenter notes to scroll through on screen and then can't work out how to move the box on PowerPoint. I've been there. Well, I probably should have learned from it more than once.
So, yeah.
Anyway, listen. We've wrapped up a few minutes ahead of schedule, I think. But it means we've got some time for some questions.
Mm-hmm.
Stephen Morawski's back at 4:35. Oh, Stephen's here to move on to the next presentation. But we've got, I think, about 10 minutes, 5 or 10 minutes. I can't quite see the clock at the back, and I'm not quite sure when we started. But we've got a few minutes for any questions. So, would anybody like to ask any questions of Andy or explore that journey or any of the stages on that journey a little bit more before we move on?
Nope.
No?
Cool.
All right, guys. Well, look, we'll give it 5 before we kick off with Stephen's presentation, just to give the guys in the other rooms a chance to wrap up and come up here if they're going to join us for the last slot. And then I think we're going straight from Stephen's as well into the final panel session in here at 5:20. So, Andy, thank you very much. That was excellent. Thanks very much.
Thank you.